In this video, we're going to focus on evaluating trigonometric functions at different angles. Now, to begin, perhaps you heard of the expression sohcahtoa. Now, do you know what it means? The S in so stands for sine. The sine ratio is equal to the opposite side divided by the hypotenuse relative to the angle theta. And I'll explain what that means shortly. Now let's focus on the co part of sohcahtoa. Cosine theta is equal to the ratio of the adjacent side and the hypotenuse. And the last one, toa, stands for tangent, is equal to the opposite side divided by the adjacent side. Now there's three other trigonometric functions you need to be familiar with too. Secant is the reciprocal of cosine, so it's 1 divided by cosine. These are known as reciprocal identities. Cosecant is 1 divided by sine. And cotangent is 1 divided by tangent. So how can we apply this information? Well, let's say if we have a triangle. Let's say here's the angle theta, and this is 3, this is 4, this is 5. So I'm going to draw another triangle. So relative to this angle theta, opposite to it is this side. So this is the opposite side. Across the box is the hypotenuse. This is the longest side. And right next to the angle is the adjacent side. So let's say if we wish to find the sine ratio, or sine theta. Sine theta is equal to the opposite side divided by the hypotenuse. So it's 4 divided by 5. Cosine theta is equal to the adjacent side divided by the hypotenuse. So it's 3 over 5. Tangent theta is equal to the opposite side divided by the adjacent side, so it's 4 over 3. Now, if you have sine, cosine, and tangent, you can find secant, cosecant, and cotangent. So secant is 1 divided by cosine, so it's the reciprocal of cosine. Since cosine is equal to 3 over 5, secant is 5 divided by 3. Cosecant is the reciprocal of sine, so it's 5 over 4. And since tangent is 4 over 3, cotangent is going to be 3 over 4. Now let's try another example. Let's say if you're given another right triangle, and this time you're given 2 out of the 3 sides. Let's say this side is 5 and this is 12, and you don't know what the missing side is. Find the values of the 6 trigonometric functions based on this triangle. So first, we got to find the missing side. When you have a right triangle, you can call this side A and B the hypotenuse. The longest side is C. And according to the Pythagorean theorem, A squared plus B squared is equal to C squared. So we could say that A is 5 and B is 12. So let's solve for C. 5 squared, 5 times 5 is 25. 12 times 12 is 144. So if we add 25 and 144, that's 169. To solve for C, we need to take the square root of both sides, and the square root of 169 is 13. So this is a special triangle. It's the 5, 12, 13 triangle. Now there are some other special triangles that you may want to be familiar with. Other than the 3, 4, 5, and the 5, 12, 13, which we covered already, there's also the 8, 15, 17 triangle, the 7, 24, 25 triangle, 9, 40, 41, and 11, 60, 61. And also, any ratios of these triangles will work as well. For example, if you multiply 3, 4, 5 by 2, you get the 6, 8, 10 triangle. That could work as well. or the 10, 24, 26 triangle. If you multiply 3, 4, 5 by 3, you can get the 9, 12, 15 triangle. Now let's find the 6 trigonometric functions. So let's label what each side is relative to the angle theta. So 12 is the opposite side, 5 is adjacent to the angle, and the hypotenuse is 13. So sine theta, according to sohcahtoa, it's the ratio of the opposite side and the hypotenuse. So that's going to be 12 divided by 13. Cosine theta is adjacent over hypotenuse, so that's 5 divided by 13. Tangent theta is opposite over adjacent, so that's 12 divided by 5. So cosecant theta, which is 1 over sine, that's 13 over 12. Secant theta is 1 over cosine, so that's 13 over 5. And cotangent theta is 1 divided by tangent, which is 5 divided by 12. Now let's say if you're given a question that looks like this. Let's say if you're given the value of sine theta, and it's equal to 8 divided by 17. And also, let's say that cosine theta is greater than 0. How can you find the other 5 trigonometric functions, cosine, tangent, secant, cosecant, and cotan, if you're given a problem in this form? Now first, you need to determine in which quadrant the right triangle lies in. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Sine is associated with the y value. So sine is positive in quadrants 1 and 2, since y is positive there. Cosine is positive in quadrants 1 and 4. Cosine is associated with the x value. And x is positive on the right side of the graph. So because both sine and cosine are positive, the triangle is in quadrant 1. So here's the angle theta. Now we know that sine is opposite over hypotenuse, and it's 8 over 17. So opposite to theta is 8. The hypotenuse must be 17. So this is the hypotenuse, and this is the opposite side. Now we can see that this is the 8, 15, 17 triangle. So the missing side must be 15. We could solve it, but if you know the special triangles, you can easily find the missing side. So now that we have all 3 sides of the triangle, we could figure out everything else. So cosine theta, which is equal to the adjacent side divided by the hypotenuse, that's going to be 15 divided by 17. Tangent theta, which is equal to the opposite side. So I'm going to put O for opposite, divided by the adjacent, so that's 8 over 15. Cosecant theta is 1 over sine, so that's 17 divided by 8. And secant is the reciprocal of cosine. So since cosine is 15 over 17, secant is 17 divided by 15. And finally, cotangent is 1 over tan, or 1 over 8 over 15, which is 15 over 8. So once you get the triangle, it's no longer difficult to find the values of the other trig functions. Now let's say if cosine theta is equal to negative 7 over 25 and sine theta is greater than 0. Where should we draw the triangle? So let's review some things. Sine is positive in quadrants 1 and in quadrants 2. Sine is negative in quadrants 3 and 4. Cosine, which is associated with the x value, cosine is positive in quadrants 1 and 4. And cosine is negative in quadrants 2 and 3, since x is negative at that quadrant. Now tangent is basically sine over cosine, which is like y over x. Tangent is positive in quadrants 1 and 3. In quadrants 1, a positive number divided by a positive number will give you a positive number. In quadrants 3, a negative number divided by another negative number will give you a positive number. In 2 and 4, tangent is negative. So knowing that, we can see that cosine is negative and sine is greater than 0, which means that it's positive. So this has to be quadrant 2. X is negative in quadrant 2, but y is positive. So let's draw the triangle here. Now consider the value of cosine, which is negative 7 over 25. Cosine is adjacent over hypotenuse. This is the adjacent side. It's negative 7 because we're traveling towards the left on the x-axis, and that's a negative value. The hypotenuse is always positive. Now this is the 7, 24, 25 triangle, so the missing side is 24. And notice that this side is traveling up in the y direction, so it's positive 24. So now let's figure out everything else. So sine theta, which is equal to the opposite side divided by the hypotenuse, that's going to be 24 divided by 25. Tangent theta, which is equal to opposite divided by the adjacent side, that's 24 divided by negative 7. So secant theta is the reciprocal of cosine, so that's negative 25 over 7. Cosecant has to be 25 over 24, and cotangent is the reciprocal of tangent, so that's a negative 7 over 24. Now let's say if tangent theta is negative 2 over 3 and cosine theta is greater than 0. Go ahead and find the missing trigonometric functions. Find their values. So tangent is negative in quadrants 2 and 4, but cosine is positive or greater than 0 in quadrant 4. So let's put the triangle there. So tangent is opposite over adjacent. So this is the opposite side, here's the adjacent side. Now which one is negative? 3 has to be positive because it's on the right side. X is positive on the right. But notice that y is below the x-axis, so it's negative. So this is negative 2. Now we need to find the missing side. So this is not a special triangle. Let's use the formula a squared plus b squared equals c squared. So we're going to have 3 squared plus negative 2 squared. 3 squared is 9, negative 2 squared is 4. 9 plus 4 is 13. So c is square root 13. So now let's find the other things. Sine theta is opposite over hypotenuse. The opposite side is negative 2. Hypotenuse is 13 or root 13. So it's negative 2 divided by root 13. Now because we have a radical in the denominator, we need to rationalize it. So let's multiply the top and bottom by root 13. So this is negative 2 root 13 divided by 3. So that's the answer for sine theta. Now what about cosine theta? Cosine theta is equal to the adjacent side divided by the hypotenuse, so 3 over root 13. And then let's rationalize it. So this is going to be 3 root 13 over 13. So now we know that cotangent is the reciprocal of tangent, so that's negative 3 over 2. Now what about cosecant? We know it's the reciprocal of sine. Don't flip this answer of sine. It's easier if you flip this one. So it's simply negative root 13 divided by 2. And the same is true for secant. Flip this answer so that the radical is on top. So that's going to be radical 13 divided by 3. Now let's say if the terminal point is negative root 3 comma 6. And given this point, you want to find the 6 trigonometric functions. How can you do it? So the first thing you want to do is you want to plot the point. So negative root 3 is in the negative x direction, and positive 6 is in the positive y direction, and then draw the triangle. So this is negative root 3, this is 6. Let's find the missing side. So a squared plus b squared is equal to c squared. We need to find the hypotenuse. We have the adjacent side, the opposite side, and we're missing the hypotenuse. So it's going to be negative root 3 squared plus 6 squared is equal to c squared. Negative root 3 times negative root 3 is positive root 9, and the square root of 9 is 3. 6 squared is 36. So this is 39, and so c is the square root of 39. So now that we have all three sides, we could find the 6 trigonometric functions. Sine theta is going to be the opposite side, which is 6 divided by the hypotenuse, so root 39, and we need to rationalize it. So this is 6 root 39 divided by 39. Now we can reduce it. 6 is basically 3 times 2, and 39 is 3 times 13. So we can cancel a 3. So therefore sine theta is 2 root 39 divided by 13. And cosecant theta is the reciprocal of sine, so flip this part of the sine function. So it's going to be root 39 divided by 6. So now let's solve cosine. So cosine theta is adjacent, which is negative root 3 divided by the hypotenuse side, which is root 39. And at this point, we can reduce it. Root 39 is basically root 3 divided by root 13. So these two cancel. So cosine is basically negative 1 over root 13. And now we can rationalize it. So it's negative 13, or negative root 13 divided by 13. So this is cosine theta. Secant theta, you want to flip this part of cosine. So secant theta is negative root 13. Tangent theta is equal to the opposite side, which is 6 divided by the adjacent side, which is negative root 3. So if we rationalize it, it's going to be 6 root 3 divided by negative 3. And 6 divided by negative 3 is negative 2. So tangent is negative 2 root 3. Cotangent, let's flip this part. So it's negative root 3 divided by 6. In trig, sometimes you'll have word problems, which is usually the shape of a right triangle, and you either got to find a missing side or a missing angle. So let's start with solving for the missing side. Let's say if you have a triangle that looks like this. So here's the right angle, and you're given the acute angle of 35 degrees, and you're given the adjacent side. Let's say it's 150, and what is y? Or what is the height of the building, or something like that. What can you do to solve for y in this particular problem? What trig function would you use, sine, cosine, or tangent? So notice that you have the opposite side and the adjacent side. Therefore, tangent is the appropriate function to use. Tan 35 is equal to the opposite side divided by the adjacent side. So to solve for y, Let's multiply both sides by 150. So 150 tangent of 35 degrees is equal to y. Now let's type this in. Make sure your calculator is in degree mode. Tangent 35 is about 0.7002. Multiplied by 150, the answer is about 105. So that's the value of y. Now let's say if we have a triangle that looks like this, and the angle is 43 degrees. We're given the hypotenuse, and we're looking for x. What trig function should we use in order to solve for x? Should we use cosine, tangent, or sine? So notice that we have the adjacent side and the hypotenuse. So according to sohcahtoa, we want to use cosine. So cosine theta, or cosine 43, is equal to the adjacent side x divided by the hypotenuse. So that's 100 cosine 43 is equal to x if we multiply both sides by 100. Cosine 43 is about 0.7314 times 100. That means x is about 73.1. Try this one. This time, instead of finding the missing side, we need to find the missing angle. Now we still need to decide what trig function to use. So 12 is opposite to theta, and 17 is across the box, so it's the hypotenuse. Therefore, we have to use sine. Sine theta is equal to the opposite side divided by the hypotenuse. But in order to find theta, we need to use the inverse sine function. Theta is going to be the inverse sine of 12 divided by 17. So the inverse sine of 12 over 17, that's about 44.9 degrees. So that's how you can find the missing angle. Use the inverse trig function. Let's try some simple word problems. A man measures the angle of elevation from the ground to a building to be 37 degrees. If the man is 700 feet away from the base of the building, how tall is the building? Now let's assume that the man's height is negligible compared to the building. So the man is currently 700 feet away from the base of the building. And here is his line of sight. So we have a right triangle. And this is going to be the height of the building. The angle of elevation. The angle of elevation is the angle above the horizontal line. The angle of depression is the angle that's below the horizontal line. So this is the angle of elevation measured from the ground to the building. So go ahead and solve for h. Feel free to pause the video and work on this example. So first we need to decide what trig function to use. So we have the opposite side and the adjacent side. So we need to use tangent. Now the angle of elevation, we know it's 37 degrees. So tangent 37 is equal to the opposite side, which is the height, divided by the adjacent, which is 700. Now if we cross multiply, 700 times tangent of 37 degrees is going to be equal to the height. Tan 37 is 0.75355 times 700. So the height of the building is about 527.5 feet. Whatever unit you have here is going to be the same unit as this side. The units have to match. Let's try this problem. The first thing we should do is draw a picture. So we have a light pole. And let's say this is the ground. Now the light pole is 30 feet tall. And it's going to cast a shadow. And here is the line of sight. And here is the horizontal line. The angle of depression, or the angle that's below the horizontal line, is 23 degrees. Now, because both of these lines are horizontal, they're parallel to each other. And in geometry, you learned of the alternate interior angle theorem. So these are alternate interior angles, and alternate interior angles are congruent. So notice that the angle of depression is equal to the angle of elevation. So now let's solve for the missing side. We want to find the length of the shadow, which is here. So let's call it x. Go ahead and solve for x. So again, we have to use the tangent ratio. Tangent of 23 is equal to the opposite side, which is 30, divided by the adjacent side, which is x. So let's cross multiply. 1 times 30 is 30, and x times tan 23 is x tan 23 degrees. So to solve for x, we need to divide both sides by tangent 23. So x is 30 divided by tan 23, and tangent 23 degrees is about 0.4245. 30 divided by 0.4245 is about 70.7 feet. So that's how long the shadow is, given the information presented in this problem. Now let's spend some time talking about the unit circle. So the unit circle is basically a circle with a radius of 1. So if we draw a triangle, we can call this side x and this side y, and r is 1. Let's call this theta. So according to sohcahtoa, sine theta is opposite divided by the hypotenuse. The opposite side is y, the hypotenuse is 1, or r. So sine theta is y over r. But in a unit circle where r is 1, sine theta is basically the y value. Cosine theta is the adjacent side divided by the hypotenuse. So cosine theta is x divided by r. Tangent theta is sine over cosine, or opposite over adjacent. So tangent theta is y over x. Now sometimes, let's say if you want to find the terminal point, if you want to find the xy value of that point, if you rearrange this equation and solve for y, y is r sine theta. X is r cosine theta. So if you ever need to find the terminal point, and if you have the angle and the r value, you can use those two equations. Now you need to know the degrees that is associated with this unit circle. So over here we have 0 degrees, this is 90, 180, 270, and a full circle is also 360 degrees, which is equivalent to 0 degrees. Now you need to know what these values are in radians. 90 degrees is equal to pi over 2 radians. 180 is equal to pi. 3 pi over 2 is 270, and 2 pi is 360. So 2 pi is a full circle or full rotation. Now you need to be able to convert from degrees to radians and radians to degrees. So let's say if we have a 30-degree angle, how can we convert this into radians? To convert degrees to radians, multiply by pi divided by 180. So the zeros will cancel, and this is basically 3 pi over 18. 18 is 6 times 3, so we can cancel the 3. So 30 degrees is equal to pi over 6 radians. Let's try another example. Convert 150 degrees into radians. So just like before, we're going to multiply it by pi divided by 180 degrees. So we can cancel a 0, and so this gives us 15 pi divided by 18. Now 15 is basically 5 times 3, and 18 is 6 times 3. So we can cancel a 3. So the final answer is 5 pi over 6. So 5 pi over 6 radians is equal to 150 degrees. Now we need to work backwards too. We need to be able to convert from radians to degrees. So let's say if we have 4 pi over 3 radians, how can we convert it to degrees? To do so, multiply it by 180 divided by pi. You want the pi values to cancel. So 180 is basically 60 times 3. If 6 times 3 is 18, 60 times 3 is 180. So we can cancel a 3. Now 6 times 4 is 24. So 60 times 4 is 240. So 4 pi over 3 is equivalent to 240 degrees. Let's try one more example. Let's try 5 pi over 9. Let's convert that to degrees. So let's multiply by 180 divided by pi. So these two will cancel. 180 is basically 5 times 18 times 10. And 18 is 9 times 2. So we can cancel a 9. Now 5 times 2 is 10, and 10 times 10 is 100. So 5 pi over 9 is equal to 100 degrees. Now there's something called coterminal angles. You need to be able to find a positive and a negative coterminal angle. So let's say if we want to find the coterminal angles of 30. To find another positive coterminal angle, add 360. So that's going to be 390. To find a negative coterminal angle, subtract 360, which is negative 330. Now let's talk about what it means. So 30 degrees is in the positive, it's in the first quadrant. 390 is also in the same quadrant. This is 90, 180, 270, 360, 390. So notice that 390 and 30, they land in the exact same position. The same will be true for the other negative coterminal angle. This is negative 90, negative 180, negative 270, negative 330. So if you have a negative angle, you need to travel in the clockwise direction. If you have a positive angle, you need to travel in the direction opposite to a clock. That's counterclockwise. So coterminal angles are angles that exist at the same location. So sine 30, for example, is 1/2. Sine 390, because that's a coterminal angle of 30, sine 390 is also 1/2. Sine negative 330 is also 1/2. So coterminal angles will have the same trig value of other coterminal angles. Now, what if you're asked to find the coterminal angles, one positive and one negative, given an angle that's in radians? Now, instead of adding or subtracting by 360, we want to add and subtract by 2 pi, because 2 pi is 360. So let's add 2 pi to it. This is 2 pi over 1. Now we need to get common denominators. So let's multiply 2 pi by 7 over 7. So what we have now is 5 pi over 7 plus 14 pi over 7. 5 plus 14 is 19. So this is the positive coterminal angle. To find the negative coterminal angle, instead of adding 2 pi or 14 pi over 7, subtract by 14 pi over 7. 5 minus 14 is negative 9. So it's negative 9 pi over 7. Now, another term that you need to be familiar with is the reference angle. You need to know how to calculate a reference angle, because that's going to help you to evaluate trig functions that is greater than 90 degrees. For example, if you want to find the value of sine 120 or cosine 240, you want to do so by finding the reference angle if you don't have access to a calculator or the unit circle. So let me give you the equations that you need to find the reference angle. So if you're given an angle in quadrant 1, the reference angle is the angle in quadrant 1. The reference angle is an acute angle. It's an angle between 0 and 90 degrees. Now, if you have an angle that's in quadrant 2, the reference angle is going to be equal to 180 minus the angle in quadrant 2. Now, for an angle in quadrant 3, the reference angle is going to be the angle in quadrant 3 minus 180. And for a quadrant 4 angle, it's 360 minus the angle in quadrant 4. So let's try some examples. Let's say if we have the angle 150. Go ahead and find the reference angle. So 150 is between 90 and 180, which means that this angle is in quadrant 2. So the reference angle is 180 minus the angle in quadrant 2. So the reference angle is 30. So this is going to be an angle of 150. And we know 180 is basically the negative x-axis. This is 90. So if this is 180 and the red part is 150, then the difference between these two must be 180 minus 50, or 30. The reference angle is the angle between the x-axis and the hypotenuse of the triangle that is formed. So 30 is the reference angle. Try this one. 240. Calculate the reference angle. So 240 is in quadrant 3. It's between 180 and 270. And the reference angle is the angle in quadrant 3 minus 180. So it's 60. To see it graphically, 240 is from the positive x-axis to this point of interest. That's an angle of 240. Now this is 180. So the difference between 240 and 180 is 60. That's the angle between the x-axis and the hypotenuse. So 60 is the reference angle. Now, what if you're given an angle in radians? How can you find the reference angle? Well, there's some things to know. 2 pi over 3, 4 pi over 3, and 5 pi over 3. These are all angles that are commonly found in a unit circle. They share the same reference angle, which is pi over 3. 5 pi over 6, 7 pi over 6, and 11 pi over 6 share the same reference angle, which is pi over 6. 3 pi over 4, 5 pi over 4, and 7 pi over 4 share the same reference angle of pi over 4. Now let's say if we don't have one of these angles. Let's say if we have an angle like 5 pi over 12. What is the reference angle? So what you could do is convert it to degrees first. So let's multiply by 180 over pi. Let's change it. Instead of using 5 pi over 12, let's use 7 pi over 12. So the pi values will cancel. 180 is basically 18 times 10. 12 is 6 times 2. 18 is 6 times 3. 10 is 5 times 2. So we can cancel a 6 and a 2. 7 times 3 is 21. And 21 times 5. 20 times 5 is 100. 1 times 5 is 5. So this is 105. Now 105 is an angle in quadrant 2. It's between 90 and 180. So the reference angle is going to be 180 minus the angle in quadrant 2. So that's 180 minus 105, which is 75 degrees. So 75 degrees is the reference angle. Because the original angle was in radians, chances are that the reference angle should be in radians as well. So let's convert 75 degrees back into radians. So this time, we're going to multiply by pi divided by 180. 75 is basically 5 times 15. And 180 is 18 times 10. 15 is 5 times 3. 18 is 6 times 3. And 10 is 5 times 2. So we can cancel a 5 and a 3. So the answer is 5 pi over 12. That's the reference angle. The original angle was 7 pi over 12, but the reference angle is 5 pi over 12. Now let's say if you're asked to find the value of sine 30. And you're not allowed to use a calculator or the unit circle. So one option is that you can memorize the unit circle, or you can use the 30, 60, 90 triangle. You do have to memorize something, either this triangle or the unit circle. Now you need to know that across the 30 is equal to 1, across the 60 is root 3, across the 90 is 2. So using sohcahtoa, sine 30 is equal to the opposite side divided by the hypotenuse. So sine 30 is 1/2. If we want to evaluate sine 60, that's going to be the opposite side of 60, which is root 3 divided by the hypotenuse. So sine 60 is root 3 over 2. Cosine 30, that's adjacent divided by the hypotenuse. Cosine 30 is root 3 over 2. And finally, tangent of 60 is opposite over adjacent, so root 3 divided by 1 is simply root 3. Tan 30 is opposite to 30 is 1, and adjacent is root 3, so it's 1 over root 3. And if you rationalize it, it's going to be root 3 over 3. Now, there's another triangle that you need to be familiar with, and it's the 45, 45, 90 triangle. Across the 45-degree angles are 1. Across the 90-degree angle is root 2. So let's say if we want to evaluate cosine 45 degrees, and let's use this angle. So adjacent to that angle is 1. The hypotenuse is root 2. So it's 1 over root 2. And if we rationalize the denominator, cosine 45, we could see that it's going to be root 2 over 2. Sine 45 is also root 2 over 2. Tangent of 45 degrees is going to be opposite over adjacent. 1 over 1 is just 1. Now let's say if we want to evaluate sine of 150. 150 is not in the 30, 60, 90 triangle, nor is it in the 45, 45, 90 triangle. So what can we do here? This is when reference angles become important. You want to find the reference angle of 150 because they're going to have the same value. They may differ in sign, but the magnitude is the same. So what is the reference angle of 150? First, find the quadrant in which that angle lies. 150 is in quadrant 2. It's between 90 and 180. The reference angle for an angle in quadrant 2, it's 180 minus that angle, which is 150. Therefore, the reference angle is 30. So what you want to do is find out what is sine 30. Now, based on the 30-60 triangle, which I drew earlier, we know that sine 30 is a half, which means sine 150 is going to be either plus a half or minus a half. So now you need to use the quadrants to determine the sign. In quadrant 2, y is positive because it's above the x-axis, and sine is associated with the y value. So sine 150 is positive 1/2. Now what about cosine 210? What is the value of this particular trigonometric expression? So first, let's find the reference angle. 210 is in quadrant 3. It's between 180 and 270. And the reference angle in quadrant 3 is the angle in quadrant 3 minus 180. So that's 210 minus 180, which is 30. So the reference angle is 30 degrees. So now let's evaluate cosine 30 based on the 30, 60, 90 triangle. And earlier we said that cosine 30 is root 3 divided by 2. Now what about cosine 210? So 210 is in quadrant 3, and cosine is associated with the x value. X is negative on the left side, which means that cosine 210 is negative root 3 over 2. Now what about tangent 330? Try that one. So 330 is in quadrant 4. It's between 270 and 360. The reference angle in quadrant 4 is 360 minus the angle in quadrant 4, which is 330. So the reference angle is 30. So we need to evaluate tangent of 30 degrees. So let's draw the unit circle. I mean, not the unit circle, but the 30, 60, 90 triangle. So across the 30 is 1, across the 60 is root 3, across the 90 is 2. So tan 30 is opposite over adjacent. So that's 1 over root 3. If we rationalize it, it's going to be root 3 over 3. So now tangent 330, is it positive root 3 over 3 or is it negative root 3 over 3? Which one? Tangent, if you recall, is negative in quadrant 4. In quadrant 4, x is positive, but y is negative. So tangent, which is y over x, negative divided by a positive number is negative. So tan 330 is negative root 3 over 3. Now what if you have an angle in radians? Let's say cosine 2 pi over 3. How can we evaluate this function? One option you could do is simply convert the angle to degrees and just repeat the steps that we did in the last example. But let's see if we could do it without converting it to degrees. So once again, you want to find the reference angle. And we know that for 2 pi over 3, 4 pi over 3, and 5 pi over 3, the reference angle is pi over 3. So we need to find cosine pi over 3. Now this you do need to convert to degrees, but it helps if you know what the values are. Remember, pi is equal to 180 degrees. So pi over 3, which is 180 divided by 3, is 60. So make sure you commit this to memory. Pi over 3 is 60. Pi over 4, 180 divided by 4, that's 45 degrees. And pi over 6, or 180 divided by 6, is 30 degrees. Knowing that will save you a lot of time. So we're looking for cosine pi over 3. So let's draw the 30, 60, 90 triangle. So across the 30 is 1, across the 60 is root 3, across the 90 is 2. So cosine 60 is adjacent divided by the hypotenuse, so it's 1/2. So cosine 2 pi over 3 is something 1/2. Now we just got to find out, is it positive or negative? 1 pi over 3 is 60 degrees. That's in quadrant 1. 2 pi over 3 is 120 degrees. That's in quadrant 2. 4 pi over 3 is 240. That's in quadrant 3. 5 pi over 3 is in quadrant 4. It's 300. So we know that cosine is negative because x is negative in quadrant 2. So this is negative 1/2. Let's try this one. Tangent 11 pi over 6. So what is the reference angle of 11 pi over 6? The reference angle is simply pi over 6. And pi over 6, we know it's 30 degrees. Tangent 30, we did that already. That's root 3 over 3. Now 11 pi over 6, you need to know that this is in quadrant 4. 1 pi over 6 is quadrant 1, that's 30 degrees. 5 pi over 6 is 150, that's in quadrant 2. 7 pi over 6 is 210. So if you remember, pi over 6 is 30, 5 pi over 6 is 5 times 30, which is 150. 7 pi over 6 is 7 times 30, that's 210. 11 pi over 6, which is in quadrant 4, that's 11 times 30, which is 330. But tangent in quadrant 4 is negative. Tangent is negative in quadrants 2 and 4, but positive in 1 and 3. So therefore, we know that it's going to be negative root 3 over 3. Now, let's say if we wish to evaluate sine of negative 120. What would you do in this case? So if you have a negative angle, you want to find a positive coterminal angle. So add 360 to negative 120. Negative 120 plus 360 is 240. Sine negative 120 and 240 have the same value. Next, find a reference angle. So 240 is in quadrant 3. So the reference angle is going to be the angle in quadrant 3 minus 180, which is 60. So we need to find the value of sine 60. So using the 30, 60, 90 triangle, we know that it's root 3 over 2. So what about sine 240? 240 is in quadrant 3. And in quadrant 3, y is negative because it's going down. So sine 240 is negative root 3 over 2. And since 240 and negative 120 are coterminal angles, they have the same value, negative root 3 over 2. Now, what if you have an angle that's larger than 360? Let's say 570. What's cosine 570? In a situation like this, you want to find a coterminal angle that's between 0 and 360. So if your angle is negative, add 360. If it's more than 360, subtract by 360. If it's in radians, add or subtract by 2 pi. So 570 minus 360 is 210. So we need to evaluate cosine 210. Now let's find the reference angle. 210 is in quadrant 3. So the reference angle for an angle in quadrant 3 is the angle in quadrant 3 minus 180, which is 30. And we know that cosine 30 is root 3 over 2 based on the 30, 60, 90 triangle. Now cosine 210 is in quadrant 3, and cosine is negative in quadrant 3 because x is negative towards the left. So cosine 210 is negative root 3 over 2, which means that cosine 570, which is a coterminal angle of 210, must be the same, negative root 3 over 2. 210 and 570, they both land in quadrant 3. That's why they're both negative. Now what if you have this one, secant of 240? What would you do to evaluate this function? Well, you need to know that secant is 1 divided by cosine. So secant 240 is 1 divided by cosine 240. So we got to figure out what cosine 240 is. So we got to find the reference angle. 240 is in quadrant 3, and the reference angle is going to be the angle in quadrant 3 minus 180, which is 60. And cosine 60, according to the 30, 60, 90 triangle, it's going to be across the 30 is 1, across the 60 is root 3, across the 90 is 2. So cosine 60 is adjacent over hypotenuse, so that's 1/2. Now what about cosine 240? If cosine 60 is 1/2, cosine 240 is going to be negative 1/2 because cosine is negative in quadrant 3. So what is 1 divided by negative 1/2? 1 divided by 1/2 is 2. You can figure this out by multiplying the top and bottom by 2. 2 times negative 1/2 is negative 1. So 2 over negative 1 is negative 2. So secant 240 is negative 2. Try this one. Cosecant 5 pi over 3. Cosecant is 1 divided by sine. So we need to find out what sine 5 pi over 3 is. So let's find a reference angle. The reference angle of 5 pi over 3 is pi over 3. And we know pi over 3 is 60 degrees. And according to the 30, 60, 90 triangle, sine 60 is root 3 over 2. Now, 5 pi over 3, if you convert that to degrees, well actually you don't need to. If you know pi over 3 is 60, 5 pi over 3 is just 5 times 60, which is 300. 300 is in quadrant 4. And in quadrant 4, sine is negative because the y value is negative. It's going down, which is below the x-axis. So sine 5 pi over 3 is negative root 3 over 2. So now we can find out what cosecant 5 pi over 3 is. So let's multiply this fraction, top and bottom, by 2. So here the 2's cancel. And what we have now is negative 2 divided by root 3. So we need to rationalize the expression. Let's multiply top and bottom by root 3. So the final answer is negative 2 root 3 divided by 3. That's cosecant 5 pi over 3. What about this one? Cotangent negative 4 pi over 3. Cotangent is 1 divided by tangent. So we need to figure out what tangent negative 4 pi over 3 is. So what we could do is get rid of the negative angle by adding 360 or 2 pi. So let's get common denominators. Let's multiply this by 3 over 3. So negative 4 pi over 3 plus 6 pi over 3 is 2 pi over 3. So therefore tangent 4 pi over 3 is the same as tangent 2 pi over 3. Now what is the reference angle of 2 pi over 3? The reference angle is simply pi over 3, which is 60. And we know tangent 60 is simply root 3. Now pi over 3, which is 60, is in quadrant 1. 2 pi over 3, which is 2 times 60, that's 120. That's in quadrant 2. Tangent is negative in quadrant 2, so it's negative root 3. So tangent negative 4 pi over 3, which is a coterminal angle of 2 pi over 3, is the same. That's also negative root 3. So cotangent is 1 over negative root 3. So we need to rationalize it. Therefore, cotangent negative 4 pi over 3 is negative root 3 over 3. This is the answer.